our room ended up being double booked, so we were supposed to be in the theater, but ended up here. And one of our presenters, his flight is late, so hopefully he'll make it here. If not, we've got a backup plan there. So after kind of a slow start here, hopefully we'll have quite an exciting evening. Just out of curiosity, how many people, this is your first meeting of our season? And everyone's been, oh, there's one person. How many people here have been, say, 2 times in the season? Someone's been here every time? Okay, just trying to get a sense of how we're doing here. So tonight, sort of IP is our topic. As IP is becoming more real, one of the things that's kind of important is interoperability, making sure that products can work together. So Jack, our first speaker, will be talking about sort of interoperability tests that's going on, so we can sort of make IP real for everyone. Then we've got 2 presentations talking about some of the technology for getting like 4K over IP and some of the technologies that help enable that. Then also last month we did the remote session sort of between Canada and the States. Today we're gonna push that even farther. Our go-to meetings between Canada and Europe. So hopefully that will work well. Maybe a little bit of lag, but we'll see how that goes. So first up here is Jack Douglas. Jack is the VP of Marketing and Business Development for PacketStorm. Jack's a member of the VSF, the Video Services Forum Board of Directors. He's a recipient of the Technology and Engineering Emmy Award. So he has an Emmy himself. He's the chairman of the Video Services Forum, Methodology for Test, FEC, Interop Workshop Working Group. Ooh, that's tough. He's chaired the ANSI TAI TRR 30 subcommittee. He's done some work with Dash. He's authored numerous articles, books on data communication. He was an instructor at the University of Alabama and Athens State University. Jack's extensive experience in standards work, interoperability testing, and VSF participation has made him uniquely qualified to present on the Video Services Forum and interoperability testing. And we'll hand it over to Jack, and I'll get your presentation up.
Thank you very much, Lee. Thank you. Good evening. You have to change.
Multitasking.
Perfect. Thank you. How's everybody this evening? Great. So I'm with PacketStorm. We make network emulators. I'm also with the Video Services Forum, as he talked about, and I chair an interoperability group there. And so what we're going to talk about tonight is how to do interoperability testing and interoperability testing that we've done in cooperation with SMPTE, the EBU, some other organizations to test some of the newer technologies out there, such as SMPTE 2022, J2K, some of those kinds of things. Okay. So the Video Services Forum was created back in 1999. It's an international type of organization. It has, as part of its membership, service providers, users, manufacturers, and we focus really on making sure that different technologies interoperate with each other. We try to make sure that it's a quality kind of a product that are created by these standards that we have, and we help educate the industry on networking technologies. And we do this through various meetings that we have, and each one of these has different sessions, much like what you're having here, where we have speakers come in and talk about various technologies. So we help identify networking technologies and various issues associated with them. And we, as part of all this, exchange non-proprietary information. So we have these interoperability events where different companies, and this last interoperability event that we just had 11 participating companies. And so we help create a standard, and then we have all the different companies interoperate with each other, and then they exchange problems that they might have, right? So when something doesn't work, this company works with another company, works with the other company to try to make things work properly. And this works very well to help the whole industry for this whole technology. These are the companies. There are about 70 of them. that are members of the Video Services Forum. And I have another page of them here as well. So you can see there's quite an assortment of companies. There are a number of activity groups that we have had over time. We have had a WAN over IP. We first started working on the COP3 type of standard. This is what became the SMPTE 2022 1 and 2. So we worked on the standard in the VSF and then introduced it into SMPTE to release it as a standard. Then there was a COP3 VBR, which became the 3 and 4. And then in 2007, there was a video over IP demonstration. This was really the first kind of interop that took place then. Then there was a QoE, quality of experience type of a joint effort that took place with ATIS. Then there were some test and measurement groups, and then SMPTE 2022 over Sonnet SDH group. And then there was a video content project. So this is much like the SMPTE videos. There are these video clips that are like 15 seconds long to allow you to test encoders and decoders. And so those are currently at SD. So in the VSF, we created a series of clips which are at HD and can be down encoded to be at different rates as well. So that you have clips that can test encoders and decoders, and they have special content in them that would be difficult to encode and decode by the way it was filmed and the type of content that is there. So those are available. Then we worked with the 32NF to create SMPTE 2022, 5 and 6, and 7. And 5 and 6 are FEC, forward error correction, and 7 is hitless. So the VSF created the standard, and then we released it through SMPTE. And the HBRAV group is one that really created those standards, and then they released it by cooperating with SMPTE. And there's still ongoing work there to improve that and add some additional things like timestamps and mirror variations and minor variations of the packet lengths here. And then hitless protection allows for seamless diversity switch type of operation here, where you can have two separate paths of video and guarantees that even if one path went down totally, that I would not lose the video. And things like places like Fox Network is using this today on their network, and they have 10 gig links between Los Angeles and the Woodlands, which is Houston, Texas, and they broadcast all of their video over that hitlessly to guarantee that they never have anything lost between those two locations. And they're using this technology to do that. And then this methodologies for testing FEC and Interop Workshop is the group that I chair here, and that is to actually test all these technologies. So we work on creating the standards for it, and then we figure out how to test it and verify that the standards do what they say that they should be doing, and make sure that there aren't any holes in the standards before it's released. And then if we find anything else, we try to fix those things in the standard. And then even after there's maybe a problem, maybe we do an addendum to the standard to make sure that everything works well as it's released into the industry. And then J2K, and this is what the Emmy was received for, is the BSF TR01, and this is transport of J2K broadcast profile video over MPEG-2TS over IP. And there was a liaison with this with DVB and EBU, and they are currently working on a low latency version of this and a 4K version of it. So that work is still ongoing, even though J2K has been released as a document. And there was an interop that we just occurred a few weeks ago, and will be occurring also again at the end of the month at the VidTrans conference of a number of different companies for this. And there's RTCP signaling, and this would be a recommended practice, and this would be to handle in-band signaling offline versus online status of media streams and data flows. And there's SVIP, this is a work group that's currently working on doing video over IP without SDI in it. And then the Joint Task Force is a Joint Task Force of Professional Network Streaming Media. Its name is JTNM. And so this is a cooperation between SMPTE, the EBU, and the VSF. So there are 3 groups working on this. It's quite a large number of people. Maybe as many as 300 people attend the go-to meetings for this. And what they're trying to do is look out into the future and figure out what architecture is needed for video. What are the problem areas? How do we need to head into the future? What projects do we need to work on? What's the next things that are needed for IP? So not only are we trying to create standards that are needed today, make sure that they interoperate, but we're also trying to look into the future. That's really what the VSF is all about. Okay, Video Services Forum. And working with other standards organizations such as SMPTE to do all that. Any questions? And I welcome questions as we go along here. Okay. So the VSF, Video Services Forum in Vegas, Las Vegas, received an Emmy Award for this work. So this was National Academy of Television Arts and Sciences for their work on J2K. The 2004 Technology and Engineering Emmy Award for Standardization and Productization of JPEG 2000 Interoperability. Every year we have a VidTrans conference, and at this conference there are exhibitions that take place, and there are interoperability events that take place demonstrating the technologies that we're currently working on, and there are speakers that speak at each one of these events to educate the public on current technologies that are going on. And this one will take place at the end of February in Marina del Rey. This is what the InterOp typically looks like, and you'll have several racks and a number of screens where you're going to compare different companies. And this was actually from a previous year. This year there's going to be 4 racks because there are 11 companies participating in the InterOp. Okay. Very complex. So the InterOp Plug Fests that have actually been going on since 2005. We had the first one back in 2005 with COP3, and it's come clear down here to February and January of this year, where we have tested J2K, SMPTE 2022 6 and 7, which would be a 270 meg, 1.5 gig, and 3 gig with FEC hitless protection. And then we did 2 and 7, which would be with an MPEG-2 TS stream and hitless protection. That would be like a J2K type of a stream with the hitless image protection. Any questions about that? Okay. This is what the setup would be to configure all that. So you see it's very complex. Lots and lots of different streams there. Everyone has 2 streams to do that. And for J2K, these are the types of tests that we ran. You can see here we had 1080i 5994, and we were testing with FEC with the 10 by 10 matrix. We tested audio and video with lip sync there. We tested ancillary data with closed caption, AFD, timecode, and SCSI 104. We made sure that everybody interoperated. And there were companies that had problems as we did that. And what we would do is work together to try to figure out, what was wrong. Hey, maybe you had something reversed, and you go help the other company fix that. That's the whole idea of this. It's a workshop, trying to figure out what's going on to help improve the whole industry. And then we did all the same kinds of tests at 720p, 5994. And then this is the 2022 5 and 6. So this would be at 270 meg, 1.5 gig, and 3 gig, forward error correction. And these are the participating companies that we had here. And this is how you would run this test. So we're going to have what we call a burst drop, latency or delay, packet delay variation, packet loss or bit error rate, and forward error correction involved. So we have an encoder and a decoder. We're going to monitor at this end. So we have a video server here, and then a real-time monitoring of the video to make sure that there are no errors in that video. Okay? And these are the test cases, and I'll go into them a little bit in detail with you. So we looked at all the corner cases. What's the worst case situation? What we wanted to do was stress it to the edge to see if it would fail. And if you don't stress them to all the edges, then you actually miss some parts, right? And as we're running through the tests, people say, well, you know, why don't we skip these? These all appear to be working fine, right? And every time as I go down through it, gosh, we found somebody that had a problem when I ran this test. Right? And as we ran some of those, we actually found some problems with the standard that we had to go fix. So we went and tweaked the standard. And so it was really important to run all these tests in all these different ways. Okay? So we set up all the different corner cases, and this table is for 270 meg, and we ran all the different rates, and we found different performance at all the different rates. Now you say, well, gee, maybe if you just ran the test at 3 gig, you would expect people would work well at 270. That was not necessarily the case. Because even though it's a lower bit rate, there were people that had worked very, very well at 3 gig and didn't work well at 270. So we really had to test at all the different rates. So we did it at 270, 1.5 gig, and at 3 gig at all the different rates. So we did jitter at 0.1, 1, and 10 milliseconds. This is how you would set it up in the network emulation. We did what's called a controlled burst. And with controlled burst, what you do is you have a burst of packets that are lost, and then you have a gap, and a burst of packets and a gap. And you do this to the media packets, and you knock out an entire row of packets. And if you want to knock out one additional packet, it will fail. And so if the FEC is implemented properly on the system, then that will work right. Right? You want to monitor the bandwidth of the rows and the columns and make sure that they're really putting out the rows and columns that you think that they're putting out. Okay? And I do that for each of the rates as well. And this is the different matrix sizes that I use. And then I do a random packet loss, and I do that at 0.0016% and 0.1%. This is how you would set it up. And then I do FEC aware tests. And in this case, what we're going to do is we're going to find the M bit, then we're going to knock out a burst of packets in the active video. And so if you turn off the FEC, what you'll see is a line on the screen. And you can actually move that line around to different spots. Depending on how well they have implemented their technology, this may lose sync altogether. It may cause all kinds of problems that may not be expected. You may pass all the other tests and fail this kind of a test. You turn on FEC and the line goes away. Here's where the M bit's at, and then knock out a burst of packets, X number of bits after that. And this is how you would set the thing up. And then the next thing that I do is a knockout matrix. And here I knock out an entire column and an entire row of packets. And if the FEC is implemented properly, they can correct for this in their equipment. And if I knock out one more packet, it will fail. And I can create any kind of pattern that I want on here. And I can even tell if they've done a double pass on the FEC. Because if they have done a double pass, they can actually correct for this one. If they haven't, they will fail on this test. Right? So depending on how it's been implemented, you can tell what's going on with the technology and what's been implemented within. Okay. And so this is a summary of all the tests that were run. For this, there are 37 tests altogether. And we test all the combination of all the companies that are there. Make sure that everybody works on all. Takes a lot of time. And this is the seamless hitless protection. And the test set up for that. And the one was done at low bit rate, 1 gig, and the other one was done at 10 gig. There's some seats over here. You're welcome to come across. Thank you. You're welcome. Then need to stand. Okay. And the hitless seamless is even more complex in how much you test this. So you're going to have 2 paths. You're going to have sync burst loss, latency, packet delay variation, packet loss, and FEC testing is all part of this test. So you really combined all the things that we've been talking about together in one test, but now you have it in 2 paths as well. Okay? And so we do what we call a zebra pattern. So we take the RTP sequence number and we set a bit in one path, say the 8th bit, to 0. And in the other path, we set it to a 1. And so we never knock out the same packets in both paths. And we toggle back and forth between those and cause packet loss between them. So we start out easy to see how everybody works. First, you actually interoperate just to make sure everybody works. Then you begin to run the test more complex. And this is how you would set all that up in the equipment. Then we add latency. Just add delay to the same test. Okay. Then we do this if you have the low bit rate, like 270, or you have high bit rates, which would be 1.5 and 3 gig. There are a different set of tests for each one of those for the delay. And there are different classes that you can have. Class A, B, and C, depending on what the receiver is designed to handle. Okay? And we test for each of those classes. Is it a class A, B, or C type? So in this test, what we do is we have the zebra pattern, we have latency, and packet delay variation. So we've added all 3 things together. So we add the knockout pattern, packet delay variation, and latency all at the same time. So this is really, really hitting it hard. It's a very, very difficult test. And almost everybody, hardly any companies make it through running this test. Okay? Most of them have to tweak things, make some adjustments. They'll really separate one company from another. Okay? This is how the whole test setup works for it. And then we have bit error rate and packet loss. And again, we add the zebra pattern so we don't knock out the same packet in both paths, because you don't want to have an error that you can't correct for. And this is how you would set up that. And this is the whole set of tests that you have. There are 15 tests in all that you would run with this. Okay. Any questions? You're all speechless. So the next thing that would be the next logical step to this is having PTP. Okay, where I take a 1588 clock and I put timestamps on all this so that I have timing protocol, precision timing protocol associated with all of it so that I can have timing across all of it. So 2059 allows you to do that. And that's just coming out now. You have 2 versions of it, -1 and -2. -2 is the timing for television. There's a profile for that. So I'm currently working with the SMPTE group, and we're trying to figure out how we want to test this. And so what I'm giving you here is kind of a preliminary idea of how you might want to do this. We might do this in SMPTE, or we might do this in cooperation with VSF and SMPTE. We don't know. This is a preliminary look at how all of this might happen. So you would have 2059 as a grand master, video source, SMPTE 2022 5 and 6. This would be 1.5 gig, 3 gig, and 270 megabits. You would have a network emulation, which could have 1 gig, 10 gig interface on it. And you have over here multiple displays that are all synchronized to the Grandmaster over there. I'm going to cause various kinds of errors in both the PTP stream and all the kinds of tests that we just talked about. You add all those together, right, along with the PTP timing. And then you have a reference that is not impaired. And what should happen is I do not lose any synchronization between those two. Okay? It should hold steady even in the presence of the impairments with the PTP taking place. That was the logical way it connects. This is the physical way it would connect through a PTP type of a switch like this, and it would have a setup like you see here. So first you would start out just testing the PTP piece of this, and you would test without any impairments, just to make sure that everybody's able to handle 2059 for it. Then you would do a studio kind of environment, which is a LAN kind of environment with short delays. Okay? And then you would go to the longer delays. So this would take over steps. Maybe this would take 2 or 3 years before we actually end up finishing this kind of interoperability testing. We want to make sure that we're able to do all the things we've talked about here. Okay? So do this at 1 gig and at 10 gig. Profile similar to 8261. Bidirectional or asymmetrical impairments. You would have delays. It would be for WAN and LAN type. You would start with the LAN type first, or studio environment. You would vary this over a time period of maybe 1 minute to 120 minutes. So it would be a slow wonder. You want to see a slow drift take place here. You also vary the jitter over time. Again, you would have a studio environment and a WAN environment. And they have different values associated with those. Do packet loss with different amounts, reordering, duplicate packets, and then you may want to filter on certain packets and do things with those, and you may want to automate it with typical control. And then you want to maybe do specific impairments on certain kinds of packets, such as the sync or delay request. Maybe you want to delay those packets and see what happens to it. And then you want to do packet drop on things like the announce, follow-up, delay response. And then you maybe want to modify the header of certain kinds of packets. What you have here. The types of equipment that was used here are a 6XG, and this is a hardware network emulator, a Hurricane, which is this is an appliance, and a capture replay system to be able to capture all these packets, make sure what with the PCAP kind of capture at nanosecond accuracy to make sure what the problems were there and see what was going on. Okay. Do you have any questions or answers? Any things you want to talk to me about? Yes.
How does this change when we go to 4K?
More complex. And as I talked about with J2K, they are looking at 4K right now at doing all that. So you would take and add more things to this whole thing. That adds one more layer of complexity to it. Absolutely.
Any thought about 8K
or? 8K just makes it faster, and for the but when you get with J2K with the lossless kind of compression, it's just a matter of a higher bit rate and more compression involved with it. But it's the same technique that you would use here. And we still have to interoperate with all the different companies. So if I would just take that J2K table and I want to run all the same kind of tests, right, with it. Have I answered your question?
Yeah.
Okay. Anything else? Yes?
Are you collaborating with entity in Japan or European?
So Sony is part of this.
Actually, Jack,
Yes.
since we're recording this, can you repeat the question to the mic?
Okay, that's right. Are we working with NTTV in Japan or anybody in Japan?
European.
Or European companies?
Yeah.
Yes, so the EBU is involved with this, as you maybe saw in some of the slides. The EBU actually ran some parallel tests to what we did, and I went over to the EBU and helped them run some of the tests. These tests were all at 59.94, as you saw. They are in March going to be running some at 50 instead. Okay, And in Japan, Sony is involved. They came here and they're going to be part of this interop that will be taking place at the end of this month. So that's the only one, but NTT is not. We welcome their participation if you'd like.
NTT because they work on the 4K, J2K.
Love to have them. You can contact me. I'm on the board of directors of the VSF. We'd love to have them. We have, like I say, service providers, manufacturers, all kinds of companies there. Okay? Anybody else? Yes, sir.
In regards to moving up to 4K, what's going to change with camera lenses, and as a result of that, the initial file sizes?
With the camera lens, I'm not really a camera lens expert. I'm sure that it has to be a better quality, but I'm not really a camera lens expert. I can tell you more about the compression and stuff like that, which is J2K compression. Is able to handle that. They have to be more complex. It's going to be a higher bit rate, but in order to be able to fit that onto a 1 gig or 10 gig kind of a pipe, you're going to have to use J2K. You can't use an uncompressed scheme. You would have to go to like a 100 gig link. Lee might be able to answer some of your questions about the compression at 4K.
Actually, we have the next presentations coming up, which will.
All right, he'll tell you some more about that. Okay. Anything else? All right. Thank you very much for your